Okay, well, welcome and thank you everybody for joining us for today's C2 Smart webinar. I am Lizzie, a research project manager at C2 Smart, which is a US DOT Tier 1 University Transportation Research Center. Today, we're joined by NYU Shanghai's Noel Joyce, who will present on Project Mjolnir, the journey of designing an open source adaptive mountain bike. When a mountain biking accident ended Noel's career in the military and left him confined to a wheelchair, he went back to education to study industrial design. Noel went on to utilize his newfound skill set to become an entrepreneur, bringing to life a number of small hardware-based startups. Traveling to and working in Shenzhen, China, he subsequently went on to become head of design at HAX, a hardware startup accelerator, where he worked with over 200 startups in the areas of robotics, medical devices, and consumer products, as well as many more industries, considering the business needs of these startups as well as their design needs. An advocate of design as a problem-solving activity with a keen interest in creating solutions to difficulties around many issues, Noel utilizes his unique prism of living both with and without a disability to create solutions to complex problems. Noel continues to apply his design capabilities to projects at NYU via Project Mjolnir and utilizes his design experience to teach design and innovation to his students at NYU. As always, we will be recording this webinar and uploading it to our YouTube channel. And we encourage everybody to ask questions by pressing the Q&A button at the bottom of the Zoom window, and we will read out your questions at the end of the presentation. And with that, I will hand things over to Noel to get us started.
Really appreciate it. Okay. Hey, everyone. Thanks for having me. This is more like a series of photos and videos that I'm going to tell a story about this project. There won't be a lot of graphs and things like that in this, so hopefully it's interesting and something that sort of is a new story. So my name is Noel Joyce. I'm clinical instructor here at NYU Shanghai. I'm a designer, adaptive mountain biker, and I'm also a wheelchair enthusiast. Sorry, just advance my slide. Okay. Has it moved forward? No?
No.
Of course. Wait, now, hold on. Let me try now. Ah, there we go.
There we go.
So, yeah, let me go back here. So let's go back in time a little. It's hard to believe that the first bicycle, which was called a Lauf machine or running machine, was invented by Carl Dreiss in 1817. So the history of the bicycle isn't all that long when you consider the simplicity of the machine. Did you know that the Wright brothers, the fathers of flight, were bicycle mechanics and applied the principles of weight and construction in bicycles to the development of their aircraft? So it's actually pretty amazing the impact a simple bicycle has had on the world. We often associate the bicycle with our first feelings of speed and lightness, almost giving us sensation of flying. The daredevils amongst us actually taking flight in these amazing machines. From BMX to mountain bikes, from racing bikes to cruisers, there's a bike for everyone and every personality. But we also remember our bikes as our first personal mode of transport, machines that took us on journeys further away from home, often with friends and family. Our first true freedom and independence is one of our earliest means of escape and adventure. And then there's the mechanical side of the bicycle. I became fascinated with the bike from an early age. I would often cobble together Frankenstein bikes from barely functioning parts in a quest to create a faster version of what I already had. This obsession led to one of my first jobs working in a bike shop in my hometown. And I worked in the bike shop at first part-time after school, but then full-time when I finished school. And I'd be out on my bike almost every day. It would be an understatement to say that bicycles were a huge part of my life. I loved working on bikes, but another career beckoned in the military, and I joined the Irish Defence Forces. That didn't mean I stopped biking. In fact, I continued to mountain bike to stay fit as well as for fun. And I eventually began adventure racing on behalf of my unit. And it was when I was out riding my mountain bike one day, training for an event, that I had an accident, and life would change forever. I'd been riding in woods I knew well, but in pretty adverse conditions. I took a fall, broke my back, leaving me paralyzed from the chest down. The impact wasn't that hard, it was just the way I fell. It was instant, and I could see my knees in front of my face, but I couldn't feel uh, my legs. And that was from the chest down. I couldn't feel a single thing, but there was an enormous amount of pain in my lower back. I was unable to draw enough breath even to shout for help. But eventually, my friend who I was out with that day came across me, and we ended up managing to get out of there eventually. Life had changed massively, and I could no longer perform my duties as a soldier, and I had to start my life over again. I'd spend the next few months in rehabilitation, and I began to learn how to survive with the new normal and figure out what I was going to do next. It was while I was in rehabilitation I began to explore what I could do for work. And I started to look around at, is there ways I can help people with disabilities? And there's just something I could solve problems for people with disabilities if I could work in this area. At 26 years of age, I went back to education and studied industrial design at the Institute of Technology in Carlow. At the end of my studies, I started a couple of small hardware-related startups and learned a great deal about the application of design to business. It was also the beginning of my journey in learning about design and manufacture, and I wasn't to know that this would lead me back to riding mountain bikes in the future. I traveled to Shenzhen, China, and ended up working at Hacks, a hardware startup accelerator where I was head of design for 8 years. While I was there, I worked on projects with over 200 hardware startups. I worked on projects in industries as diverse as robotics to medical, from consumer electronics to transport. If there's an industry you can think of, I may have worked on a project in it. But in 2019, I traveled back to Ireland just before the pandemic, and my career took another turn. I began the journey of teaching at NYU Shanghai during the pandemic. I taught my classes remotely from Ireland through Zoom, hosting my classes online. I was able to teach Fusion 360 to students on the other side of the planet. Two paths I was traveling at the time were to converge in the near future, but not how I expected. Parallel to my new career at NYU Shanghai and teaching remotely, I found myself getting back onto the bike, albeit I was on three wheels instead of two. My first bike was a rigid framed affair with simple components and no assist. It was still expensive given what it was. Regular mountain bikes are expensive for something capable. Adaptive mountain bikes are frighteningly so. Adaptive mountain bikes reach really crazy prices, with something reasonably capable costing between 8 to 10,000 US dollars. For something good, it can cost between $18,000 to $23,000, depending on specification. It was one day that my friend next door neighbor seen me out riding this bike in front of our houses and said we should go to the trails near our homes. And when we went there that first day, I got onto the trail, and it was like as if the same adrenaline was there from the first time I'd been mountain biking. So I was back on the bike after over 14 years. It wasn't long before I was out riding the bike's capability and there was frequent failures. It was a mountain bike in name only. Wheels were being destroyed. I was upgrading parts frequently in an effort to extract more performance from this bike, but ultimately there was no amount of upgrades that would make it last. All this was leading to frequent repairs. Having to weld a frame back together was taking its toll on the bike. Every time it was welded back together, it would technically be repaired, but it was actually weaker. It was also taking its toll on my pocket. And this bike was not going to last very long given the punishment it was taking. I began doing a lot of this kind of stuff, taking measurements and tweaking ideas, using a mixture of CAD and sketching to come up with form factors, trying to anticipate the limiting elements of creating a hand cycle. As hand cycles themselves are quite complex, and you have to try and come up with ideas for steering and the drive, because the drive was on the front fork as well. So there was multiple rounds of innovation, thinking outside the box, trying to develop this new concept for a bike, given that this bike kept failing. I needed to do something different as far as the design was concerned. And I began to hunt to find someone who would help me develop my ideas and concepts into a fully fledged bike. I found a company in Spain called Carbon Master who took on my ideas and built the world's first carbon fiber full suspension adaptive mountain bike. Over the course of a year and lots of back and forth conversation, this was the result. The single build took quite an effort to execute on, as there were so many unknowns involved. While the company had built many road bikes before, they'd never built anything like this. I received the bike and immediately got out onto the trails. The bike offered so much more capability and range. It was equipped with an assistive drive, which allowed the rider to go further distances over terrain that was a bit more difficult. There were many problems with this bike, as the terrain I was venturing onto was beginning to take its toll on it. While carbon fiber is a super material, when it fails, it's not a great situation. And unfortunately for me, I was about to find this out. On a ride in the mountains, on a trail I was used to, I hit a set of undulations that pitched the bike into the air at the rear, and on impact I heard it crack, and then the bike hit the ground and slid along the trail, splintering carbon fiber as it went. The bike had an unplanned rapid disassembly at the molecular level at one of the rear suspension structures. One of the carbon fiber A-arms disintegrated, leaving me stranded in the forest. It was around 5 kilometers from the car park, and with no way out. As a wheelchair user, you don't walk out from these situations. It was scary to be in such a vulnerable position again. I say vulnerable as it was a little bit like the time I crashed almost 16 years before. Even though I wasn't injured, it was still a pretty scary scenario. But with the ingenious invention that was the cable tie, we got the bike out. When I got home, I reached out to the company who made this particular bike and asked about the cost of repairing this component. They told me it was going to cost about 500 euros and it was going to take about 6 or 7 weeks to repair this part. For those with disability, it's often the case that you don't have the same amount of time to enjoy the sports or things that you do because your body deteriorates that much quicker. It gets more difficult the further you go into your disability to be able to enjoy these things. So for most people with disabilities, you might as well tell them it's going to be 6 months as 6 weeks. It was also the case that I had no choice but to use this manufacturer to make the part, which meant that the same for any other person with a disability. They have no choice. They can't go to the local bike shop to get the part. They have to rely on the manufacturer. And the cost was something I was worried about too. So prohibitive cost, plus the fact that it was going to take so long, sort of got me thinking, I need to change this. I need to be able to make sure that this never is a problem for me again, and see if I can solve this issue for myself and for others. Within 2 weeks of that decision, I had redesigned a part, and I had sent those files to be machined, and I had a full set of 4 A-arms for half the price of the single carbon one. These arms were made from 7075 T6 aluminium. Admittedly, they were very simple and heavy, but I knew they wouldn't break. To me, it was a miracle that I could get back on the bike that quickly, given the previous timeline for the carbon fiber part. More importantly, what I knew now was that I could solve the problems for myself, and decided that I would design an entire bike to be easier to build, faster to build, affordable to build. And I decided that when it was finished, the files would be open source, so no one who built one could find themselves in the helpless position I had not long ago been in. Utilizing the software I'd been using for designing bikes, I designed the entire bike from beginning with new ideas and concept. I designed the most complex variant, a full suspension bike on which we could work backwards to simplify. Over the next few months, I spent hundreds of hours working out problems, creating specific geometry based on the characteristics I wanted from the bike, and figuring out how it would be assembled. This was the beginning of the open source adaptive mountain bike. I was learning a lot very quickly, and Fusion was aiding me in this. And as I developed my designs, I became more capable of helping my students with more complex problems at NYU Shanghai. I was getting better at design, and my students were benefiting from that experience. Giving the new bike a name seemed to solidify direction. There's something about a name that makes it feel more real. I called it Project Mjolnir, and there were a few core tenets I wanted to stick to in its development. It was to be customizable, affordable, repairable, and evolutionary. It also had to be possible to build it anywhere. I built the first one at the back of my kitchen, utilizing a space not larger than 6 by 9 feet to assemble it from my wheelchair. It started with basic construction of PVC pipe and foam core to establish space envelopes for parts. Evolving through stages of construction, as and when parts arrived, the bike began to take form in this same space. On completion of this build in January of this year, I was tentatively optimistic about the result. There it was, it existed. After a little over 7 months from the crash that caused the carbon fiber part to disintegrate to the build of this bike, it seemed like a miracle this bike existed. The first test of the bike went unusually and surprisingly well, considering the amount of issues I had assumed and anticipated. I'd also assumed a lot of positive things, and many of them had worked out. I think it's a trait in designers to constantly doubt our capabilities, and it was showing up in force for me with this bike. However, I shouldn't have worried so much. It was a great feeling to test this bike and even manage to get over that jump that broke the carbon fiber bike previously. I traveled to New York to teach for the fall semester of 2022. This was before I had finished that first build. And while I was there, I spoke to a number of my colleagues about the project. It was then when I was introduced to Maria DeCoon, who heads up the VIP program at NYU Tandon School of Engineering, and she suggested we apply for the Spring 23 program. The VIP stands for Vertically Integrated Projects. They're longer-term projects carried out at NYU, often multi-year and multidisciplinary, incorporating innovation and research to help students get hands-on experience developing solutions to real-world problems. There are over 50 projects in the program with thousand plus students involved, and it's a really great initiative with some great people driving it. At this time, my co-instructor on the project, Phil Greedy, and I had applied for and were successful in getting into the program. We quickly got to work reaching out to contacts to see if we could drum up some support for our ambitious plan. We were going to build 4 bikes, 4 locations around the world within the first year. The objective being that we could prove that we could build a bike quickly and easily anywhere that could be repaired, upgraded, developed on site when needed or desired. We were incredibly fortunate to get the support of Specialized Bicycles and SRAM bicycle components, who provided us with help by way of parts for those bikes. The concept for Mjolnir is as follows: a modular platform that allows you to build any one of 4 variants. The frame can be upgraded when the customer requires it and can be repaired quickly if you do manage to break a part. It utilizes standard off-the-shelf bicycle components for its running gear, most of which is available from any bike shop or online bike store. The entire structure does not require a single weld to hold it together and uses standard length fasteners to bolt together. Frame component gets damaged, it's easily replaced or repaired, and most things can be sourced and made within 2 weeks. For the next 3 months, the Project Mjolnir team worked remotely, utilizing Fusion 360 to develop the new parts that would form the simplified, more affordable bike. Meeting weekly and in contact daily, the design quickly evolved, and on a tight schedule to design a bike and have the parts made, we execute on this phase in 7 weeks. This left us with 3 weeks for parts to be made and shipped from China. We couldn't afford any large errors. In preparation for the assembly, we were fortunate to receive support from Sean Van Every at ITP NYU Brooklyn in finding a space to build this bike. In April of this year, having never sat in the same room, the team comprising Phil Greedy, Guglielmo Fonda, several other staff and students, and myself, began assembling the first bike with no idea would it come together. Over the next 3 days, we worked tirelessly. We had some hiccups around fasteners, some issues on part fit tolerance, which we were largely able to solve on site. Every issue was recorded and amended. On April 24th of this year, we took the first adaptive mountain bike in New York City across the Brooklyn Bridge on its first ride. It was the first adaptive mountain bike to be ridden on trails in New York City not long after that. Our common language was the software that we had used, Fusion 360, which enabled us to view the design remotely before we even started building the bike. There was always a reference for us to look at, even though we hadn't assembled one before. It acted like an instruction manual for us to assemble a bike, and it also allowed us to make important amendments to ensure the next build went more smoothly. This is Phil Greedy and Guglielmo Fonda assembling Mjolnir. Luke Bunn, who's not in the pictures here, he was instrumental in its success. It was a crazy few days at NYU in Brooklyn. We were living out of the vending machines, essentially, in trying to get this done. But we got there in the end. And in July of this year, the first bike took to the trails of Fresh Kills Park in Staten Island, piloted by Rachel, seen in this picture, under the guidance of Matt LeBeau and the New York City Mountain Bike Association. It was the first time that Rachel had ridden a bike in 15 years. And it's incredible to believe that we'd only embarked on this design journey earlier in the year. We have another ride planned for this fall where we hope more people with disabilities will experience the thrills of adaptive mountain biking in New York. Of course, there was tweaks to be made, and this was carried out with Laura Shengan, who has been aiding our parts development and manufacture in China. We spent some time implementing the changes we needed from the first build into the manufacturer BOM and sent those files for manufacture while I was preparing to go to NYU campus in Abu Dhabi to build bike number 2. The second bike was assembled in Abu Dhabi at the NYU campus there. We aim to begin the build in mid-June. In order to get a clear idea of facilities for the build, we were able to discuss design, the phases of the build, and the space required for the build at NYU Abu Dhabi in advance. We also reached out to the Abu Dhabi Cycling Club and TrailX at Hudaydah Island where we could test the bike. With the prior knowledge of the first build, this bike was assembled in less than 2 days. Again, Fusion played its role because before I arrived in Abu Dhabi and before the parts got there, students could access the files and understand what they were going to be working on. And under the guidance of Jorge Moltavo and Ted Lee, we got this bike done even faster. Again, Fusion played its role. Before I arrived there, the students were active in building the bike, and now we had a global project, 2 bikes at 2 locations in 3 months. one in New York and one in Abu Dhabi, we'd have proven that we could build a bike in multiple locations. I know it was only 2 locations, but it was still multiple. We also made another little bit of history by riding the first adaptive mountain bike in the UAE on trails in the UAE. Scott Canny, Director of Athletics at NYU Abu Dhabi, working with Wolfie's Bike Shop at Hudayrat Island, ensured we could achieve this. It was a test of real-world conditions and a lot of fun into the bargain. We also did a 40-kilometer night race that same day, which really tested the bike build and my own endurance. Bike 2 still had some tweaks, but it was running well. The bike in Abu Dhabi was also ridden by Ahmed, pictured here. Ahmed will be trying the bike again this fall as we develop it at the campus. We're also utilizing this project to teach students in Abu Dhabi. They will reverse engineer and try to improve component design as part of their studies. The project itself is a beacon of inclusivity at NYU's diversity inclusion efforts, and we look forward to building more bikes there, where an extensive cycle lane network has been developed as part of Abu Dhabi being a UCI designated cycling city. The third bike was built in Ireland and is an iteration of the original design. The design incorporates more parts being made by laser cutting in an effort to cut down costs further at the manufacturer stage. The evolution of the frame will be cheaper and easier to manufacture and will be the basis of the design files released on open source. And this bike will be utilized in Ireland by wheelchair users, giving them the opportunity to experience the thrill of mountain biking. In another piece of good news in relation to this, someone reached out to me offering to sponsor the build of another bike at a mountain bike trail centre in Ireland. So it's no longer inconceivable to believe that one of these bikes could exist at every mountain bike trailhead in the world if we can get support on a local level like this. We were now at 3 bikes built in 3 locations in 5 months, one in New York, one in Abu Dhabi, one in Ireland. We had once again proven that we could build the bike in multiple locations. The 4th bike will be built in Shanghai, and we believe it will be the first adaptive mountain bike in China. We look forward to trialing this bike at trails later this year or early 2024. All 4 bikes will see further development this fall semester and early 2024 as we continue to develop the platform and add features to those bikes. While we haven't built a bike here in Shanghai yet, we have been busy creating prototypes of the next generation of suspension design, which you can see here on this picture. And this day next week, all going according to plan, the 4th and final of the first 4 bikes we set out to build will be completed. We will do this build in the campus here at NYU Shanghai. So far, we achieved the objectives we set out to achieve, and we will continue to develop the platform. We will be releasing the design files to the public for those wanting to build a bike for private use. We hope to build a community of riders, builders, innovators, as well as continue to develop this platform as an educational experience for learning about design and manufacture. So what's next for Project Mjolnir? What's next for Project Mjolnir? Well, the frame set has already evolved, and we hope the community will add to the value of that by utilizing the files to build on what we've done so far. We'll also continue to seek more industry partners to get involved in the project. I myself would love to see a bike everywhere you see a city bike, for example. Maybe this can be another form of micro mobility platform. We will continue to utilize NYU's world-class prototyping capabilities at LaGuardia Studios and Tandon in New York City. There are incredible resources such as 3D metal printing, which will aid in the construction of functional structural parts not achievable by regular manufacturer techniques. It opens up the possibilities of bespoke control interfaces for Mjolnir for specific needs of individuals. We can explore how we can help people with varying abilities as a result. Machining and manufacturing capabilities at NYU Abu Dhabi will help us to further refine frame design and design test multiple variants. Having on-site capability further reduces lead times to a part design and ultimately an answer to whether a part is going to work or not. Design and development at NYU Shanghai will help to educate students while advancing Project Mjolnir. Utilizing tools at hand to advance the concept, knowledge that is developed here can be shared and deployed at all other sites where the project exists. Being able to design and develop and deploy a project on a global scale will give students at NYU an insight into how to manage a project like this, a truly global project at the global university network. The project itself encompasses so many things. It's about education, it's about evolution, and importantly, it's about inclusion. It's about taking something that was out of reach and making it accessible to more people. It's the pursuit of knowledge in doing this and the development of empathy while doing this that will help students at NYU design and build for people regardless of ability. We believe that a bike can be built by an individual for much less than the cost of what's on the market currently and upgraded as and when they need to do so, breaking down the barrier of entry to getting involved in the sport. We think some of the next steps are in generative design and how we can optimize further and explore other ways to make parts. How can we optimize material use? How can we make a part more efficient? All this work's moving us towards a more accessible future. And while I've spent the last 35 minutes or so talking about an adaptive bike, this bike may well be a platform that spawns innovations. These innovations we may not realize we need in the future. If I was to ask anyone here, and I know no one can answer me, but I'll explain what these three things have in common, it might not be believable at first blush. All of these products in this image started life as something to help a person with a disability. The typewriter, which the keyboard is a descendant of, was created to help someone who was losing their vision to communicate. The electric toothbrush was designed to help people with limited dexterity and motor function to be able to brush their teeth. And the audiobook, or Audible as we know it today, originally started out as talking books, which were recorded on vinyl records for people who had lost their vision coming back from the First World War. So things that are ubiquitous to us today, items that we use every single day, that we that began life as accessible technologies. The status quo exists, even though we might not realize it. And we think that Mjolnir might have even fragments of that kind of DNA in it, that we might be designing things for the future by working on this bike. For me personally, it's to try to provide the feeling of flying, the feeling of the sense of speed and excitement, to be totally immersed and absolutely focused on this exhilarating experience, to get back onto the trails and to help others to get back onto the trails, to go somewhere for the first time, to go somewhere where it was impossible to go before. To get back into nature and have those adventures, to help physical and mental well-being in those with disabilities. When Rachel and Ahmed could get back on a bike, it was to them a great day. Something that when you can utilize a regular bike is easy to take for granted. We hope that this project can move us another stretch towards more people with disabilities having great days all the time, and close the gap in being able to do so more frequently. Project Mjolnir, as much as it's an educational platform, is a means to promote freedom and independence for the biggest minority group in the world. And with that, I will answer any questions anyone might have. I'll stop sharing.
Great, thank you. As a reminder, we invite all questions, so if anybody has one, you can enter yours now by pressing the Q&A button at the bottom of the Zoom window. We have one right now, which is there a way any current wheelchair users can get involved in the project in a participatory capacity?
Yeah, if you want to reach out to me, like Elizabeth, if anyone reaches out, looks for my email address, tell them to reach out to me, because we're always like right now we're in that development stage where we're going to finish the first version of the bike shortly, the frame set, and we want to get a few people involved in building bikes as well. So if anyone wants to reach out, or if there is a wheelchair user that actually wants to try the bike as well, we have one in New York. If it's in New York, we can definitely do that. Just reach out to me. We can start that conversation. Yeah.
Cool. And then I don't see any other questions. If you're typing it, please keep going, and then we can get to you. And the person says, "Thank you. I'd like to test it in New York." So we can work to get that set up.
Yeah,
Great.
for sure.
All right, well, thank you everybody for joining, and to Noel for your presentation today. A recording will be made available in November after your presentation on our center's YouTube channel and website. And as always, this webinar is brought to you by C2 Smarter and USDOT's University Transportation Center program. So thank you everybody, and have a good day.
Bye-bye from Shanghai. See you all. Bye.
Good night. Thanks.